Okay, I'm going to work out these two more examples for you, and then we're going to talk about a couple of other things. So on this example number 4, we're going to work this out. So we have A is 1, B is negative 10, and C is 16. So first thing we're going to do is work out our axis of symmetry. So x is equal to negative b divided by 2a. Our b value is negative 10. A is 1. Remember that negative 10 has to be in parentheses because that negative goes outside of it as well. So the negative and negative makes a positive. 10 divided by positive 2. So x is equal to 5 in this case. So 5 is what's going to go in our middle section here. We still need to find our y value. So you remember you can plug it into this, plug in your x value here to find out what y is going to be equal to. Or we can also use our calculator. So with our calculator, I'm going to go that route today so you can see that in this example. So y is equal to, we're going to plug in x squared minus 10x plus 16. And then we are going to go to our table. So we know that the vertex, the axis of symmetry, is going to be at 5. So we can actually go on down to 5. And we're going to look at our y value. So the y value for 5 is negative 9. Okay. Then we're going to go up 3 points. We're going to go to 4. And the y value is negative 8. And then we're going to go to 3. And the y value here is negative 5. And then we're going to go up to 2. And the y value is 0. Okay. And then we're going to go back down. And we're going to go the other direction. So 6. And the y is negative 8. 7. And the y is negative 5. 8. And the y is 0. Hopefully you're seeing a pattern with these tables and what they look like. All right, so let's go ahead and talk about what we know about this table as we go to graph it. So the a value is 1. It's positive, so it's going to open up. And if it's opening up, then our vertex is actually a minimum, meaning it's going to open up from that point. We know that the axis of symmetry is 5. So 1, 2, 3, 4, 5. We're going to have a vertical, invisible axis of symmetry here. Our vertex, or our minimum, is at negative 9. And then we can plot these other points. So 4 is negative 8. 6 is also at negative 8. 3 is at negative 5. And 7 is also at negative 5. 8 is at 0. And 2 is also at 0. And then we can draw our parabola from there. Okay, remember our domain is going to be all real numbers because all of these x values are used. Y values are only going to be from this negative 9 up. So y is going to be greater than or equal to negative 8. There are going to be no more y values below that point. It is the minimum point. All right, so we are looking for the solution, the root, the 0, whatever you want to call it. And this one has a root here and here, okay? And so what we're going to do is we're going to notice that x is equal to 2 and x is equal to 8 in this case. Okay, so x is equal to 2 and x is equal to 8. All right, that's the place where these cross. All right, and the last example that we're going to do is y is equal to negative x squared plus 9. So in this, we have an a value of negative 1. We have no b value, and c is 9. So we're going to plug this in. Y is equal to negative, and remember our b is 0, and our a is negative 1. So we end up with 0 divided by negative 2. So x is equal to negative 2 in this case. So we can plug in negative 2. Oh, I'm sorry, it's 0 in this case. My bad, y'all. know that sometimes I skip ahead. 0 divided by negative 2 is 0, so I apologize. 0 is our axis of symmetry, which means it's going to be this line right here. Okay, forgive my blunder. Now we have to look for the y value for our vertex. Okay, so y value for our vertex, we can actually plug it into our calculator. All right, I'm going to clear out what I did before. We're going to do negative x squared plus 9, and we're going to look at that table. So we know that it's at 0, and it goes with 9. And then we're going to go up, negative 1, 8, negative 2, 5. And then we're actually going to keep going, and it's going to be negative 3, 0. And then we go down 1, 8, 2, 5, and 3, 0. Okay, so your y values are not always going to be some version of 0, 5, 8, and 9. I know that it came out that way on the 3 examples that we did, but it is not always going to be the case, okay? So don't get into that habit of thinking that that is going to always be the correct answer, because it is not. If you do number 6 as an example, you will not have that the same y values, okay? All right, so back to this. We're going to go ahead and graph it. Remember that this is a negative 1, so it's going to open down, which means our vertex is going to be a maximum this point. So we're going to be at 0, 9. Then we're going to have negative 1, 8. We're going to have 1, 8. We're going to have negative 2 at 5, 2 at 5, negative 3 at 0, and 3 at 0. Okay, and then we're going to just draw that parabola, and then our x-intercepts are going to be these two numbers right here. So x is going to be negative 3 and 3. All right, that's going to be our final answer on these. Okay, so those are a couple of examples that I promised that I would do with you. Very quickly, we are going to talk about the bottom of these notes, which is called the discriminant. Okay, discriminant is what we use to determine the number of solutions. And you have seen the discriminant before. This is the discriminant. And previously, we called this the factor test. Okay, so the factor test told us whether or not something could be factored into two binomials. Okay, it did not tell us whether or not we would have solutions. So the discriminant uses that same factor test to determine whether or not we're going to have 0, 1, or 2 solutions. So just because something couldn't be factored didn't mean that it didn't have solutions, but it could mean that. All right, so we're going to look at this. The discriminant is b squared minus 4ac. So once you plug these values in, once we solve that, then we're going to look at that value of d, the discriminant, and we're going to decide if it's greater than 0, equal to 0, or less than 0. So if it's greater than 0, if it's a positive number, then there are going to be 2 solutions. If it's equal to 0, there's going to be 1 solution. And if it's less than 0, if it's a negative number, there's going to be 0 solutions. So we're going to use that real fast, do a couple of examples here, and then we'll be done with this, okay? You'll see a couple of example problems for you to work out on your own. So we're going to use this formula, b squared minus 4ac. So this right here, we're going to use b is 5, so 5 squared minus 4 times 1 times c, which is 4. All right, so we're going to have 25 minus 16, which is going to be 9. Okay, so in this case, if we were using this as a factor test, we would find out that we can factor this into two separate binomials. If we're using it as a discriminant, if d is equal to 9, it's a positive number, it's greater than 0, so there are going to be 2 solutions. Okay? Let's see. Let's go ahead and do number 8 as well. So now we can plug in this negative 3 squared minus 4 A is 1 and C is 10. So we end up with 9 minus 40, which is a negative 31. Okay, negative 31 is not a square, so by factor test, we would not be able to factor this. Okay, but by discriminant, it means that there are going to be 0 solutions. Okay, so that is something to consider on these. Okay, so that means we're going to have 0 solutions there. It's a negative number. All right, we're going to do one more example. We're going to do number 9. So in number 9, we have b squared. So 10 squared minus 4 times 1 times c, which is 25. And we're going to work that out. 100 minus 100, which is equal to 0. Now 0, we decided before when we've done examples, is a square because 0 times 0 is 0. So I can factor this. This is something that can be factored. But by discriminants, it means that there's only going to be one solution because it's equal to 0. Okay, so here, this is something that could not be factored, had no solutions. This one, we could factor it, but it only had one solution. And this one we could factor it and it had 2 solutions. So just something for you to think about. These are all connected, and you're going to start seeing that as we work out more examples. So this is factor test to decide if something could be factored into 2 binomials, but it's also the discriminant to decide how many solutions you're looking for when you go to work this out. So what this means is that this one is going to be like the examples we've done, where you're going to cross the x-axis twice. This example is not going to cross the x-axis. It's either going to be above it or below it, but it's not going to cross it. And then this example is only going to have one solution, meaning the vertex is somewhere on the x-axis, and it's either going above or below that, but it's only going to have one solution. So hopefully that all makes sense. I'll do a few example problems. If you need any help with anything, let me know. I'll give you guys a few examples to work out, and then we're going to start using this a little bit more next week.